Okay, so this is just a practice for Chapter 8, the math part, all dealing with solutions. So in class, we talked about sort of 4 math topics, all dealing with concentration. So the first one we talked about is molarity. So remember, that's that capital M. So if you see in a problem, you see anything like, say, 1.75 M HCl. Remember, just take that capital M and convert it to what it means as units, because the M is kind of like saying a dozen. It's just sort of a random unit. So we want to take this M and change it back to 1.75. That is moles per 1 liter. Okay, so that capital M is moles per liter. Same thing if you see percent. Percent is just a unit value, like a dozen, but it doesn't tell you how many of those. So percent solutions, you can have percent solutions are always how much out of 100, right? Like an 80 out of 100 points on a test. So this is always going to be some amount of solute out of 100 of the solution. But if you're talking about mass, it would be grams of solute per 100 grams of the solution. So if you see percent, so if you see like 8, so if you see 8% NaCl and say that it is mass to mass. So if it's M over M, then just convert that percent. That means that you have 8 grams of NaCl per 100 grams of the solution. It's not per 100 grams of water, it's per 100 grams of the solution. So remember, that would be the water and the sodium chloride's masses together. Now, if I have volume to volume, then that is going to be mils per 100 mils. So if I have a 20% solution of ethanol, that means that I have 20 mils of ethanol, because it is the solute, divided by 100 mils of the total solution. So that would be the ethanol and the water. Now, I will tell you the most common one that we use is the mass to volume, because mass is like the grams of some solid dissolved in the solvent of water. So if you make up a 10% glucose solution, and it is mass to volume, that means that you put 10 grams of glucose per 100 mils of the solution. Okay, so see how it's always some amount of solute divided by 100 amounts of the solution. So it might be grams, it might be mils, it just depends on which type it is. So always take the percent and convert it back. Parts per million, parts per billion. Always put your values, put your mass units into grams, put the volume units into milliliters. So if you want to know parts per million, you take grams divided by the milliliters times a million. Parts per billion, grams divided by milliliters, and put it as times a billion. Okay? Last one. Last one is really this part goes down here. So dilution is looking at a change in concentration by adding water. So the initial concentration is always higher. The final concentration is always lower because you're adding water to it. So the volume, final volume, is always going to be the higher volume. The initial volume of that concentrated solution is always going to be less. So just like gas laws, make sure that you determine the known 3 values and which one you're trying to find. So if you're always going to use this formula, C1V1, that is the initial concentration in volume. C2V2, that is the final concentration in volume. And so just make sure you rearrange the formula. Apply significant figures once you solve. So I gave you a couple. I just wanted to go through a few, showing you how to work these ones out. So some of these are just like ones we've done. Stop the video, try to solve these, then check to see if you did them right. What is the molarity of a 2.5 liter solution? So I know that this is my volume, of sodium bicarbonate, which contains 47 grams. So I know the mass, right? Mass is in grams, liters is volume. So I know mass in liters, but I want to know molarity. So I know molarity is that capital M. So remember that that is moles per 1 liter. So there's my volume. So there's the volume that to get my liter unit, but I can't use the gram amount, so I have to go from grams to moles first. So in this one, step number 1, I have to convert grams to moles. And once I do, then I can take this amount of moles and divide it by the volume that I have, that 2.5 liters, and that's going to then give me the capital M. So the first step, to go from grams to moles, I need to know the formula mass. So remember, in doing this in Chapter 3, you just take the mass of each of the atoms in the formula. So NaHCO3. Na, if you look on your periodic table, it weighs 23. H, looking at the periodic table and rounding, it's just 1. Carbon, periodic table, it's 12. Oxygen, there are 3 of them. Each oxygen weighs 16 and there's 3. So that's a total of 48. So I'm just adding up the mass of each of the atoms in the formula. So 23 plus 1 is 24, plus 12 is 36, plus 48, so 36 and 48 is 84. So there is the formula mass. 84 grams is equal to 1 mole. Well, I have 47 grams, so I have to do the math for that. So if I start off with 47 grams times in the line, I'm going to put grams on the bottom, moles on the top. 1 mole is 84. So that, I'm taking the formula mass and using it to figure out the number of moles. And then I'm going to divide these two. So if I take 47 and divide it by 84. So 47, do the math with me. 47 divided by 84, and I come up with 0.559238095. Okay, but I don't want to use all, I need to keep all of those, don't round it, I'll write all of it. 55952388095, and that would now be moles. But I've got to divide this to figure out this capital M. I need to divide it by the volume. So 2.5 liters, right? Because molar is grams, is moles per liter. So I'm going to take this number and I'm just going to divide it by 295 without doing any rounding until I get to the end. And this answer comes out as being 0.2238095238. So remember that I've got to do the rounding for this. So in my number, do you see that 2.5, that's 2 significant figures? 47, 2 significant figures. So I will take this number, 0.22380955238, capital M, and I'm just going to keep the 0.22. That's the first 2 significant figures. Remember, you keep the 0 out front because of the decimal place, but I'd only need the 0.22. The next number is a 3, so all that rounds down. So my answer would be 0.22 M, capital M molar. That is the molarity of that solution. Second one. How many grams of sodium chloride in 500 mils of 12%? So in this one, this is concentration times volume. Concentration is 12%, so I'm going to change percent to grams of sodium chloride per 100 mils of solution, right? Because that's what the percent is telling me, and then just multiply it times the volume. So milliliters and milliliters will cancel. Not that one. Milliliters and milliliters will cancel. It's going to give me my answer. So 12 times 500 divided by 100 gives you 60. 60 grams of sodium chloride in that solution. Looking at it, 12%, 2 significant figures, 500, 1 significant figure, so I can just keep this. 60 has 1 significant figure. Now, how many parts per billion is a solution of 0.125 milligrams of lead nitrate? Parts per billion, what I've got to do is I have to put my mass in grams. So I have 0.125 milligrams. I know I've got to put it in grams. I have 5.0 liters. I know I have to put this in milliliters. You have to make your units mass in grams, volume in milliliters. Then I'm going to multiply whatever this is times a billion. So I'm going to come over here and do the math. 0.125 milligrams times in a line, 1,000 milligrams on the bottom, 1 gram on top. That means that now I'm going to take 0.125 and divide it by 1,000. So that is 0.000125 grams. Now the second one, I'm going to take 5.0 liters, and I'm going to put liters on the bottom, milliliters on the top. Milli is 1,000 again. So now this will be 5,000. This answer, I'm going to multiply it times 10 to the 9th, or just make sure when you multiply, put a 1 and count the number of zeros that you put in. When you multiply, count 1, 2, 3, 4, 5, 6, 7, 8, 9. Count them. Do this part first. 0.000125 divided by 5,000. You get an equals, and then I'm going to multiply it times a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 equals. And I get 25. So I get 25 parts per billion. So it says lead levels over 20 parts per billion are toxic. Yes, this is toxic. That makes sense? Okay. Next one, final concentration. So these last two are doing dilutions. So in this, what is the final concentration of a 3.5 HCl solution if you dilute 40 milliliters to 250? So remember that this is going to be C1V1 equals C2V2. So you want to figure out what each of these is. What is the final concentration? So that is C2. What is the final concentration? That's my unknown. So I want to get C2 all by itself. So I know then that 3.5% is C1, and you are diluting it from 40 mils to 250. So this is V1 and this is V2. So plugging these numbers in, remember I have to rearrange the formula. So I need to get C2 all by itself. That means I got to divide both sides by V2, which will get move V2 to the opposite side. So I have to take then, C1 is 3.5% times V1, which is 40 milliliters, and then divide it by V2, which is 250 milliliters, and that should tell me what C2 is. So 3.5 times 40 divided by 250. And my number comes out as 0.56%. Notice that milliliters and milliliters would cancel. My answer is in percent. Now going back and looking at significant figures, 3.5, 2 significant figures. 40 only has 1 significant figure. 250 has 2. So this, I would keep the 0.5. The next number is a 6. So this would round to 0.6% HCl. So in this one, how much is going to be V2? How much can I make? Here is C, how much of this is C2.9%, 75 mils is V1, 10% sodium chloride, that is C1. How much, so much is volume, 0.9%, there's my concentration final. 10%, my concentration initial. Remember, concentration initial is always higher. So this now, C1V1 equals C2V2. So in this one, I've got to move C2 to the opposite side so that V2 is all by itself. Now I can plug in my numbers. So 10% NaCl times 75 mils divided by 0.9%. And notice in this, I could have liters, I could have milliliters. It doesn't matter. The only things you've got to make sure they are the same units are the ones that cancel. So like up here, milliliters and milliliters were the same units. I could cancel them. Here, percent and percent, same units. You can use them to plug them in. You can cancel them. So this is going to tell me the volume that I can make. So if I take 10% times 75, so that's 750, and then divide it by 0.9%, it comes out being 833.3333333 milliliters, right? Because percent and percent cancel, so it leaves me in milliliters. So looking back, 0.9%, one significant figure, 75 mils, two significant figures, 10%, one significant figure. So the 8, this would become 800. Okay, so this question. So remember when I told you, or when you were making up a percent solution or a molar solution, you really don't know how much water you can add. You just know you add enough water to make the final volume equal to what you're trying to get, because the solute takes up some room. But when you start with a liquid solution and you add water to dilute it, you can figure out exactly how much water you would use. And you would do that by subtracting the volumes. So 800 minus 75 mils would tell me that I would end up using 725 mils of water. So I would have 800 mils total. 725 mils of that would be water. The rest would be the 10%. So this is just an extra practice. I hope that you've got these ones right if you went back and did them prior to watching this. If not, I hope this helps kind of like set some things straight.